Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 6, Section 3, titled Standard Form. By the end of this video, you will have reviewed graphing equations using the intercepts. You will begin by finding x and y intercepts, then graphing lines using those intercepts, and then finally graphing horizontal and vertical lines. You'll then move on to writing equations in standard form. You'll transform equations to standard form and then finally solve a real-world problem. If you'd like me to cover any of these topics in greater detail, please leave a request in the comment section below. Please subscribe to this channel. It'll help this video to be seen by others. Thank you. So before we get started, I'd like to kick this off with reading one definition so that you're already thinking about it as we're moving forward through the review. So the x-intercept. The x-intercept is the x-coordinate of the point where a line crosses the x-axis. Very similar to what we learned in the previous lesson on the y-intercept. But now we're talking about the x-intercept. Okay, objective 1, graphing equations using intercepts. The slope-intercept form is just one form of a linear equation. Another form is the standard form, which is useful for making quick graphs. Okay, the definition here, it says, the standard form of a linear equation is ax plus by, right here, see the ax? ax, I have to change colors here. Let me change colors. ax plus by equals c, where a, b, and c are real numbers, and a and b are both not zero. One could be zero at a time, but they both are not zero, right? Are not both zero at the same time. So you can use the x and y-intercepts to make a graph. The x-intercept is the x-coordinate of the point where a line crosses the x-axis. To graph the linear equation in standard form, you can find the x-intercept by substituting 0 for y and solving for x. Similarly, you can find the y-intercept by substituting 0 for x and solving for y. Okay, example 1, finding the x and y intercepts. Step 1. Well, let's say, find the x and y intercept of 3x, right here, 3x plus 4y equals 8. That's the standard form equation of the linear equation. It's a standard form. Okay, to solve step 1, to find the x-intercept, substitute 0 for y and then solve for x. And so here I wrote the equation, 3x plus 4y equals 8. And then we substitute 0 right here, substitute the 0 for the y value. Right here's y, we're going to substitute 0. So now we get 3x plus 4 times 0 equals 8. And then guess what? The 4 times 0 disappears, and it's 3x equals 8. Right here, 3x equals 8. You divide both sides by 3, and you get x equal to 3/8. So the x-intercept is 3/8. Excuse me, not 3/8, 8/3. Excuse me, please. Step 2, find the y-intercept. Substitute 0 for x and then solve for y. It's the same thing we did in step 1, except, so we're going to start with our original equation, 3x plus 4y equals 8. And now we're going to substitute 0 for the x. So that's going to eliminate the x term, and we're going to have 4y right here is equal to 8. And that means y is equal to 2. The y-intercept is 2. Okay, so now you have those 2 points. Okay, let's move on. Okay, example 1, check your understanding. If you've been with me before, you know what this means. I'd like you to stop or pause the video and then work this out. And then when you get back, we'll do it together. So I'll wait around for you. Okay, assuming that you've stopped and paused the video and now you're back with me. It says find the x and y intercepts of 4x, right here, 4x minus 9y equals negative 12. So let's do it. So I'm going to write it down. 4x minus 9y is equal to negative 12. So we said the first thing we're going to do is we're going to zero the y. Put a 0 in for y. So we're going to get 4x minus 9 times 0 is equal to negative 12. The 9 is going to disappear. So 4x is equal to negative 12. And x is equal to negative 3. So now you found the x-intercept. So x-intercept is 3. Now let's do the y-intercept. Again, 4x minus 9y equals negative 12. We're going to substitute 0 for x. 4 times 0 minus 9y is equal to negative 12. Okay. And then what? So now I'll rewrite it so it's clearer. And, and this is not, it is negative 9y. Okay. So now it's negative 9y is equal to negative 12. And what are we going to do? We're going to divide both sides by 9. So we're going to, and the negatives are going to, by negative 9, and both sides, they're going to cancel, right? So we're going to get divide by negative 9 here and divide by negative 9 here. So the negatives will cancel. And we're going to have 12 ninths or 4 thirds. So y is equal to 4 thirds. Okay. So negative 3 is the x-intercept and 4 thirds is the y-intercept. Okay, example 2, graphing lines using the intercepts. So now we're going to use those two x and y intercepts and graph the line. So graph 2x plus 3y equals 12. What did it say? It says if the x and y intercepts are integers, you can use them to make a quick graph. So 2x plus 3y is equal to 12. So step 1, we're going to write the equation right here. And then we're going to substitute 0 for y. Here's where we substitute 0 for y. And now we're going to end up, the 3 term will disappear, and we'll have 2x equals 12. And then we'll divide both sides by 2, and we're going to get x equals 6. And then over here, then we write the equation again, and now we're going to substitute 0 for x, and we're going to get 3y equals 12, because the 2 term disappeared. And we're going to divide both sides by 3, and we're going to get y equals 4. So that's step 2. Plot 0, comma 4, okay, and 6, comma 0. That's where we have our two different terms, right? So one is the 6 with the y equal to 0, and the other is with the x equal to 0. Okay, so now we're going to do, we have those values, we're going to plot them. And when we look, what we see here is if we go to 0, comma 4, here's x equals 0, and here's y equal 4. So here, I'm doing red. So here's, oh, didn't turn. Come on, turn to red. There you go. So here's our first term, our first dot or point. And the next one is 6, comma 0. So it's x is 6 and y is 0. Okay. And then if you drew your line, it would obviously be right through here. So it's kind of quickly, it helps you determine your line, doesn't it? Okay. Okay, example 2, check your understanding. So we'd like you to pause the video and try this one. So it says graph 5, right here, 5x plus 2y equals negative 10 using the x and y intercepts, just like we just did. Okay, so I'll give you some time here and then go ahead and try it. Okay, so let's give it a try here. So I'm going to write the equation again. I'm going to say 5x plus 2y is equal to negative 10. First thing we're going to do is we're going to solve for the x-intercept. So we're going to have 5x is plus 2 times 0. We're substituting 0 for y, and that equals negative 10. So that means this term is going to disappear, and we're going to have 5x equals negative 10. And what? X will equal to negative 2. So x is negative 2. And now we'll do it again. We're going to say 5x plus 2y equals negative 10. And now we're going to substitute 0 for x. So we're going to have 5 times 0. That made the x term disappear. Plus 2 times y is equal to negative 10. Okay, so now since that x term disappeared, it's 2y is equal to negative 10, and y is equal to negative 5, right? So we have x is 2, negative 2, so we have a negative 2 comma 0 for the x, and for the y we have a 0. We substituted 0 for x, and we have negative 5. So let's graph it. So let's draw a line here, and we're 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now we kind of have a graph written out, right? X and Y. Here's x. Here's the bottom of y. Here's the left-hand side of x. So doing the x, so we have a negative 2, 0. 1, 2, here's negative 2. Negative 2 is right here. And y is 0. And here we have 0 and minus 5. So we have 0 and 1, 2, 3, 4, 5. It's right here. So this term here is what? It's negative 2, 0. That's that term there. And this one down here is 0 comma negative 5. If you draw a line through it, it's going to be something like this, right? I missed the dot, but you get the idea. Goes through this point here, and it goes to that point down there. Okay? Okay, example 3, graphing horizontal and vertical lines. You're going to see that these are special cases, but we are going to use the standard form of the linear equation. And so problem A says graph y equals negative 3. Well, this is written in standard form, except you don't realize that it isn't apparent that x is 0, right? So it's 0x plus 1. There's always a coefficient of 1 in here of the y. 0x plus 1y equals negative 3. So we can plot that, right? So when we get ready to do it, we're going to say find all values of x where y is negative 3. That's what we're looking at, all values. So no matter what value for x you put in, no matter which value, I'm going to do a nice dark color. No matter which value of x you put in, y is always negative 3. Here's negative 3 right here. Y is always negative 3. And now let's do graph x equals 2. Now we're going to graph the vertical line. So what's different here is now we have a 1x. Okay, we change back to see this. You have the 1x and a 0y. There is no y's, just x equals 2. So write it in standard form, right? 1x plus 0y equals 2. So you're going to find all values of y where x is 2. So here's every value of y where x is 2, and this goes infinitely, forever, in both directions. And you see x is always 2, so it's a vertical line. Okay? Okay, example 3, check your understanding. So we have 4 problems here, and we'd like you to pause and graph these out, just like we did the last slide. It shouldn't take long. I'll wait for you. Okay, so I'm assuming we've done that. So we're going to graph each equation. So what do we have? We have, in this case, for A, we have y equals 5. So that's 1y, right? 1y equals 5. And it's also what? 0x plus 1y. That's how we did the last one, right? There's no x term. So it's y equals 5, because you're 5 divided by 1 to clear the 1, right? So y equals 5. And what does that mean? We're going to graph it. Okay, this is telling us y is equal, here's y, up and down, 1, 2, 3, 4, 5, 1, 2, 3, we have a couple of them down. Here's all your x terms here, x's and y's, and if I say y is 5, 1, 2, 3, 4, 5, it's everything along this line, y equals 5. No matter what you put in for x, y is always equal to 5. So it's a horizontal line at 0, comma 5. Okay, how about B? Y equals 0. Well, if y equals 0, we're going to draw a graph. So just like we did before, what is x? Well, x is zeroed plus y equal to 0. So what? That means that everything here, it's everything, I'm going to do it with a different color. Everything along the line right here. That doesn't show up very good either, does it? Maybe I'll do red. Everything along the line here in both directions. Y is 0. So no matter what you put in for x, y is always 0. And they're telling us that. Y is always 0. I should do this too. Y and x. Okay? And then the graph goes in both directions. Now let's try. I'm going to go back to gold. X equals -4. So here's the chart. X is -4. 1, 2, 3, 4. We really don't need any of the other ones. It told us x is -4. Here's -4. And that's what x is. So x is everything along this line. No matter what, x is -4. Y can be anything. X is -4. Right here. Okay? And in this one here, we're going to graph that too. And this is x equals 0. And if x equals 0, that means what? That it's this way, x is 0. And it happens to be right on the y-axis also. So like this line above it, I'm going to change colors so you can see it. Let's try the red. X is 0 means that everything, no matter what you select for y, infinitely, x is always 0. So this could be, it could be, let's pick one. How about 0, comma 3? Well, here's 1, 2, 3. So if I plotted that point there, it's still, right? X, it's on the x line. It's always going to be on x equals 0. Okay, I think you've got it. Okay, objective 2, writing equations in standard form. So now we're going to talk about writing the equation from, like say, the slope-intercept form is the other form you know. We just did that in the last section. The slope-intercept, we can convert that to standard form. We're going to look at doing that as we come forward. It says you can change the equation from slope-intercept form to standard form. If the equations contain fractions or decimals, multiply to write the equations using integers. So what we want to do is you get rid of the fractions and do some type of manipulation, usually multiplication, to get rid of the fractions, okay, or the decimals. So let's take a look at that. Okay, example 4, transforming to standard form. So it says write this y equals 3/4 x plus 2 in standard form. Well, this is the slope-intercept form right here, right? So we're going to convert the slope-intercept form to standard form. Okay, so how do you do that? Well, here I've rewritten it. Y is equal to 3/4 x plus 2. So what do? We have a fraction right here. Here's that 4 right there, causing us problems. So what are we going to do? We're going to multiply both sides by the 4. And you see here, this is parenthesis here because we have to multiply the entire right-hand side by the 4. So we're going to multiply that by 4 and the y by 4, and we're going to end up with 4y is equal to 3x. Now we got rid of the 3/4. It's 3x, but the 2 became an 8 because that 4 times 2 is 8. Because we had to get rid of the distributive property right here. The distributive property took care of that. So now that you have this, you have to get the 3 on the side with the y, right? So on the left-hand side. So we're going to subtract 3x from both sides. And we're going to get negative 3x plus 4y equals 8. We subtracted 3x from both sides. So the standard form of the equation y is equal to 3/4 x plus 2 is negative 3/4 plus 4y minus 8. Okay, example 4, check your understanding. So now I'd like you to pause the video and try this on your own. It's the same as what we just did in the previous slide. And I'll wait for you. Okay, assuming you've paused and you're back, and if you didn't, I'm sorry. I wish you would have, because learning mathematics is literally, you just can't. I mean, you can watch it, but it's not. You have to make pathways in the brain. You have to do the problems. So, anyways, let's write the problem out. Y equals negative 2/5 x plus 1. Okay. And what do they tell us to do? They tell us to get rid of the fractions and decimals because you have to have integers. Okay. So in order to do that, we're going to multiply both sides times 5. So we have 5y is equal to 5. The whole right side is going to get multiplied by the 5. 2/5 x plus 1. We're going to multiply through on this distributive property to get rid of the distributive property. And we're going to end up with 5y is equal to 5 divided by 5 is a 1, so we're going to have negative 2x, because the 5's cancel, plus 5 times 1 is 5. Now, you can't have a negative, no, excuse me, you can't have the x on the right-hand side. You have to have the x on the left-hand side with the y. Well, let's just put it this way. The x and y have to be on the same side, and then the constant term on the opposite side. We're going to move the x to the left side. So when we do that, we're going to add 2x to both sides. So we're going to get 2x plus 5y is equal to 5. And that is the solution. That is y equals negative 2/5 x plus 1, which is the slope-intercept form, written as standard form, 2x plus 5y equals 5. Okay? Okay, example 5 is a real world problem. So let's look into this, see what we've got going here. It says write an equation in standard form to find the minutes someone who weighs 150 pounds would need to bicycle and swim laps to burn 300 calories. And it says use the data below. So we have the table right there. So let's write it. So let's define x and y first. So that x here, x is going to equal the minutes spent bicycling. And we see bicycling is right here. Let me go to a darker color. We have bicycling is right here. And then we have the other thing we have. Y is the minutes spent swimming laps. And we have swimming laps down here, right? And here's the calories. 150 pound person is going to, and this is calories burned per minute, right? So let's take a look at it. So let's kind of relate what they're asking and put it into words that could be turned into an equation. So 10 minutes bicycling. Okay, someone's going to do how many? The 150-pound person. Here's bicycling. It's 10 minutes. So 10 minutes bicycling plus 12. The swimming laps is 12 minutes plus 12 minutes swimming laps equals 300 calories. And that's what we want to burn, 300. So there, now we write the equation from this. And the equation is 10 times x. It's 10 times x, which we said is the minutes bicycling, times 12 plus y. And y is the minutes spent swimming laps. And that's all going to be equal to 300 calories. And there's our equation. The equation in standard form is 10x plus 12y will be 300 calories. Okay, so we're going to look at this for a second. Put it, read it over, make sure you got it, because we're going to do it again on your time. Here we go. Okay, example 5. Check your understanding. So now you can write this equation. It's really just as easy as the last one was. So write an equation in standard form to find the minutes someone needs who weighs 150 pounds would need to bowl and walk home to burn 250 calories. So I'll wait for you. I'll give you some time to pause the video. Okay, I'm assuming you've done that, and we're going to get started on it. So the first thing I'm going to do is like we did in the last one. I'm going to say let's let x equal bowling, and let y equal walking. Okay, So now we're going to write the equation. We're going to go right straight to it. And so we have x is bowling. So we're going to find bowling. It's right here. X is bowling, and it's 4 minutes. So 4, oh, change back to orange. 4x plus walking is 3.5 miles per hour. We're going to walk for 5 minutes plus 5y. And that equals, what are we looking for? 250 calories. 250 calories. And that's our equation. You just have to fill it in. And then, of course, they're saying you have to walk 3.5 miles per hour to get that 5 calories per minute. Okay? Good job, everyone.